The Changing Military Operational Environment. Gürdeniz. Today, the most important factor shaping the future of warfare is not manned platforms, but the new operational mindset created by unmanned systems. The underwater domain, meanwhile, will become the main arena of this struggle. The Russia-Ukraine war, now entering its fourth year, and the Iran-US-Israel conflict, which has lasted more than 40 days and whose effects are still ongoing, have shown the entire world that the warfare environment is undergoing a profound and revolutionary transformation. Air, land, surface, underwater, and even underground operational domains are being reshaped in terms of both symmetric and asymmetric forms of conflict. Radical changes are taking place in almost every dimension of warfare, from weapon systems and sensors to command and control structures, target acquisition, and engagement processes. Yet at the center of this transformation are, without doubt, unmanned systems. The low-cost, high-persistence, widespread availability, and swarm operation capabilities provided by unmanned aerial, ground, naval, and underwater vehicles have called into question many doctrines that have remained valid on the battlefield for more than a century. Today, the most important factor shaping the future of warfare is not manned platforms, but the new operational mindset created by unmanned systems. Transformation in the air. We can say that many armed forces around the world are rapidly moving toward the procurement and production of armed unmanned aerial vehicles, AUAVs, and unmanned combat aerial vehicles, UCAVs. Many air forces and defense companies now see fifth-generation fighter aircraft as the final major stage of the manned fighter era. For this reason, the common feature of sixth-generation projects is not merely to produce a more advanced manned aircraft, but to turn the manned platform into a system that operates together with numerous unmanned aerial vehicles. The aim is to transform the manned fighter aircraft from a platform that fights alone into a mission commander that controls the unmanned combat aircraft around it. In this structure, a significant portion of missions such as suppression of enemy air defenses, electronic warfare, reconnaissance, and high-risk strike operations will be carried out by unmanned systems, while the piloted aircraft will remain farther back and assume command of network-centric operations. Within this framework, the loyal wingman concept is developing rapidly. From the 2030s onward, mixed fleets in which dozens of unmanned combat aircraft operate alongside manned fighters are expected to become increasingly common. In this structure, the manned aircraft will not disappear entirely. However, while it shifts toward the role of decision-maker and mission manager, the elements that absorb the first blow and enter the most dangerous missions will largely be unmanned systems. For this reason, the decisive force in air warfare after 2040 will not be individual fighter aircraft, but integrated swarm systems composed of manned and unmanned platforms. Turkey's most important platforms for this concept are Bayraktar Kizil Elma and Anka 3. Both systems are being developed to operate with Tayi Khan in the future. Therefore, Turkey is already building a significant foundation in the concept of manned-unmanned teaming, which is considered one of the core elements of sixth-generation air warfare. Transformation at sea. The role of unmanned surface vehicles, USVs, operating on the surface of the sea is increasing day by day in naval operations. Within the concept of network-centric warfare, low-cost unmanned surface vehicles, which avoid the political consequences associated with human casualties, provide force multiplier advantages in reconnaissance, surveillance, target acquisition, electronic warfare, and strike missions. The ability of surface USV swarms to provide wide area control at low cost, reduce the risk of human loss, and increase the operational flexibility of naval forces is particularly noteworthy. The use of Ukrainian USVs without names, flags, or identifying marks, not only against Russian warships, but also against unarmed merchant vessels, and even within the maritime jurisdiction areas of third countries, indicates that such platforms will be used very frequently in the coming period, especially in confined maritime areas, such as the Aegean and the Eastern Mediterranean. The vulnerability of the surface. On the other hand, when today's rapidly developing satellite networks, multi-layered sensor systems, AI-enabled target acquisition capabilities, and long-range precision strike technologies are taken into account, the concealment of platforms operating on the surface is gradually disappearing. In the near future, during the first hours of a high-intensity naval war, not only major warships, but also unmanned surface vehicles will become priority targets for firepower originating from the air, the surface, and other naval elements. For this reason, in the naval wars of the future,
The surface platforms with the highest probability of survival will be small units that can exploit narrow bays, fjord-like geographies, and the radar shadows created by islands, islets, and rocks, while leaving low radar, acoustic, and infrared signatures. These platforms will be able to minimize their risk of detection by remaining motionless in their areas and avoiding the use of active sensors. Fed by passive sources of information, these units will wait for the right moment, retain the initiative to strike against opposing forces, and create unexpected effects on the battlefield. In the naval warfare of the future, superiority on the surface will not belong to the largest or most powerful platforms, but to the elements that are detected last and act at the most appropriate moment.
Underwater. When the history of naval warfare is examined, one thing remains unchanged. The underwater domain retains its mystery. Today, despite the digital revolution extending from artificial intelligence to quantum computing, the submarine's greatest ally is still the darkness of the seabed. During the Second World War, the United States fought Japan in the Pacific Theater with approximately 300 submarines, and with this force sank around 1,300 merchant ships and more than 200 warships. The merchant tonnage sunk was approximately 5.3 million gross tons. American submarines destroyed more than half of the Japanese merchant fleet and a large portion of the oil transported by sea, paralyzing the economic and military logistics system of the Japanese Empire. This played a role in Japan's surrender, at least as important as the atomic bombs. Germany, on the other hand, built 1,200 U-boats during the war and used around 800 of them in active operations. German submarines sank approximately 2,800 Allied merchant ships and hundreds of warships, sending a total of 14 to 15 million gross tons of merchant shipping to the bottom of the sea. This figure represents the highest sinking tonnage ever achieved by any submarine force in history. What made this success possible was undoubtedly the darkness of the underwater domain. During the Second World War, as German U-boats tried to cut Britain's lifelines in the Atlantic, Winston Churchill made the following admission: "The only thing that ever really frightened me during the war was the U-boat peril." What frightened Churchill was not the prospect of the German army landing on British shores. What frightened him was the possibility that the British Isles would be dragged into hunger, fuel shortages, and economic collapse, because the fate of an island state is often determined not on land, but along sea lines of communication. The Battle of the Atlantic is one of the clearest lessons in history.
Admiral Frank Kelso III, who served as Chief of Naval Operations of the United States Navy between 1991 and 1994, expressed the difficulty of the underwater domain with the following words: "We can detect a small piece of metal in deep space, yet sometimes we cannot detect an underwater object 100 meters below us." More than 30 years have passed, but this reality has not changed. This reality is the invisibility of the submarine. Today, despite the entire technological revolution extending from artificial intelligence and big data to quantum computers and unmanned systems, the rules of acoustics still prevail underwater. The uncertainty of acoustics gives the submarine an advantage unmatched by any weapon in history. Until a detection system other than acoustic energy is found, the underwater domain will retain its mystery. For this reason, both powerful states and states that remain weaker against powerful adversaries are once again turning their attention to manned and unmanned submarines. Throughout history, submarines have changed the strategic balance through their invisibility, influenced the fate of states, and often determined the outcome of wars. This is why the submarine is not merely a combat platform, but a guarantee of national survival. Today, the most effective deterrent developed by humanity is not land-based hypersonic ballistic missiles, but ballistic missile submarines, SSBNs, moving silently in the depths of the seas. This reality lies at the foundation of the continued global power status of the United States, Russia, China, the United Kingdom, and France.
The words of Admiral Sergei Gorshkov, the architect of Soviet naval strategy, were not spoken in vain. Submarines are the main force of the Navy. Mao Zedong also demonstrated historic determination when China was still struggling with poverty and famine. "We will build nuclear submarines, even if it takes 10,000 years. The strategic will behind that statement is one of the foundations of China's emergence today as a global power projecting into the oceans. Demand for the underwater domain will increase. As of 2026, there are 195 countries in the world, but only around 120 of them have naval forces. Among them, approximately 42 states, including Turkey, actively operate operational submarines. Today, global and regional powers continue to invest in submarines. The United States allocates hundreds of billions of dollars to its nuclear submarine fleet. Russia is building new Beret and Yasin-class submarines, while China expands its underwater power every year. Among these states, the number of countries operating autonomous unmanned underwater vehicles is around 15. In the 20th century, the elite club of naval power consisted of states that possess submarines. In the second quarter of the 21st century, the new elite club has begun to consist of states that operate long-range autonomous underwater systems. Today, there are around 10 countries capable of producing autonomous underwater vehicles that can operate independently underwater and carry weapons with ranges of hundreds of miles. The situation is no different for Turkey. When the Navy of the Republic was founded, Commander-in-Chief Mustafa Kemal Atatürk placed the submarine at the center of the fleet. He understood that the most effective way to defend the Turkish Straits, the continental shelf, and the Blue Homeland passed through the underwater domain. 100 years have passed, technologies and threats have changed, but Atatürk's strategic foresight has not.
Today, Turkish submarine capability continues to develop with great momentum. Semi-submersible surface platforms. Today, the world is still largely focused on conventional surface USVs. Yet, in light of what has happened over the past 4 years, the real game-changing systems of the future will be semi-submersible platforms, or platforms that operate very close to the waterline. In other words, we can say that the future operational environment at sea will highlight unmanned underwater vehicles, underwater sensor networks, and semi-submersible platforms capable of surfacing when necessary and then diving again, rather than conventional USVs. These systems, which have extremely low radar cross-sections and can conceal themselves completely by submerging when necessary, will play a critical role in both reconnaissance surveillance and strike missions. Such platforms greatly reduce radar cross-section, complicate satellite detection, make visual detection more difficult, and challenge the search and illumination radars of guided missiles. In particular, we can say that the final evolution of the kamikaze USV concept will be high-speed semi-submersible attack vehicles. When used in swarms, these systems could seriously strain the close-in air defense systems of existing warships. Underwater network architecture. Today, the most invisible and survivable elements of naval warfare are submarines. While a frigate or amphibious ship can be tracked from space by UAVs, radar, and electro-optical systems, the submarine remains the platform that is hardest to detect. Therefore, the core of future network-centric operations should be considered not on the surface, but underwater. Turkey must undoubtedly be prepared for crisis, escalation, and war in its geopolitical areas of interest in the Aegean and Eastern Mediterranean. Once a war begins, the political outcome depends on weakening the adversary's will and determination to continue fighting.
As much as destroying the enemy fleet, preventing maritime transportation, and rendering ports and bases unusable will make it easier to achieve the political objective. Beyond these objectives, projecting power ashore is also among the Navy's most important missions within the scope of joint operations. However, this option can succeed only when air and sea control or superiority has been achieved. If air and sea control has not been established in the Aegean and Eastern Mediterranean, our manned and unmanned surface forces will face the constant danger of destruction in narrow littoral waters. In this process, reconnaissance, surveillance, sensor, and command and control systems in confined areas, in short, the network-centric system, will be rendered ineffective through both kinetic destruction and intensive electronic attack. Until backup systems come online, naval elements, whether manned or unmanned, will be deprived not only of target information, but also of tactical situational awareness. This will make their destruction easier. Against the concentrated firepower that will come from the air and the surface, from ships and shore-based systems, USV swarms, TB3s, TGC Anadolu, frigates, coastal control stations, and the entire concept of network-centric operations ultimately rely on command and control nodes that operate in the electromagnetic spectrum and are largely located on the surface. However, the Russia-Ukraine war, the experience of Hormuz and the Red Sea, and recent developments in precision long-range missiles have shown that the greatest vulnerability of network-centric warfare is the network itself. Although a flagship such as TGC Anadolu may be envisioned in the future as the command center for numerous USVs, UAVs, and other unmanned systems, it will also become the most valuable target for the enemy.
If this command center is disabled as a result of a ballistic missile, hypersonic missile, cruise missile salvo, or swarm attack, the risk arises that the entire network could collapse. In such a scenario, even if dozens of USVs and UAVs are present in the field, joint operational capability could be largely paralyzed.
Therefore, in the naval warfare of the future, the true center of gravity must be ensuring the survivability of the command and control network. In this context, a second paradigm shift is needed. In parallel with a surface-centered network architecture, an underwater-centered network architecture must be established for strategic, operational, and tactical situational awareness. The SOSUS, Sound Surveillance System, used by the United States and NATO during the Cold War, is an important example. Through hydrophone networks deployed in the Atlantic and Pacific, Soviet submarines could be tracked from thousands of miles away. Today, with artificial intelligence, quantum sensors, distributed acoustic sensing, and seabed communication systems, much more advanced versions of this architecture can be established. Turkey must also develop a blue homeland underwater network consisting of fixed and mobile sensors in the Black Sea, the Aegean, and the Eastern Mediterranean. This network could enable a continuous flow of information among seabed sensors capable of LOFAR TRN measurements, autonomous underwater vehicles, acoustic listening systems, seabed data centers, manned and unmanned submarines, autonomous underwater vehicles, USVs, and UAVs. In other words, my proposal is to create a long horizon beneath the sea. Conclusion. In the coming period, it will not be sufficient for Turkey to invest only in classic underwater force multipliers such as Milden, the objective of nuclear-powered submarines, the Akya heavyweight torpedo, and Gezgin and Atmaca missiles.
In addition to these, semi-submersible reconnaissance, surveillance, and strike platforms, many unmanned submarines capable of launching UAV, UCAV, or torpedo attacks from underwater, autonomous underwater vehicles capable of conducting independent missions for long durations, and distributed underwater sensor networks will play a decisive role in the future operational environment. Especially when the complex geography of the Aegean Sea, composed of numerous islands, islets, and rocks, is taken into account, establishing a blue homeland underwater reconnaissance and surveillance network is becoming a strategic necessity for Turkey. This network will provide the Turkish naval forces with continuous and uninterrupted situational awareness during periods of crisis, escalation, and war. Turkey must establish its own national underwater network architecture in the Aegean, the Eastern Mediterranean, and the Black Sea. In the naval wars of the future, superiority will belong not only to the side with superior weapon systems, but to the side that can see without being seen underwater and continuously generate information.